Welcome. This is the lecture for Chapter 37 on Public Goods. First, a word about math. This is a screenshot I took from section 37.4 of our book. Calculus is a prerequisite for this course, but only Calc 1, single variable. I think it's mostly differential calculus. Now, most of the calculus we've seen so far in this course has been either that, or at most, taking a partial derivative. If you know how to take a simple one variable derivative, taking a simple partial derivative, not that big a leap, and I showed you how to do that. However, this is multivariable constrained optimization using Lagrange multipliers. It's not as bad as it looks, but this is beyond what I can expect of you, given that only Calc 1 is a prerequisite. So, when you see math like this, as is beginning to pop up in these last few chapters, if you understand it, fine. If you don't worry about it. I'm not going to ask you to do this on a test. Okay. Now, there are two qualities of goods that we need to look at. You probably remember these from your principles course. One is whether the good is excludable or not. The other, whether it's rival or not. Excludable means you can prevent someone from consuming it. In practical terms, excludable means you can force people to pay for it. Non-excludable, you can't prevent someone from consuming it, also means you can't force them to pay for it. Rival. A rival good is one where your consumption reduces the total amount available for other people to consume. Non-rival good, your consumption does not reduce what's available for others. When you think of a good, most of the time you're thinking of a private good, which is both rival and excludable. Think cheeseburgers. It's rival. If I eat a cheeseburger, it's not available for you to eat. Also, it's excludable. I walk into McDonald's, say, give me a cheeseburger, please, and I refuse to pay them, they can say, no, you're not getting a cheeseburger. Now, rival goods that are not excludable, we call common resources. I wrote here sea fish, because the word ocean wouldn't fit, to differentiate from fish in a lake. A person can own a lake. You can be prevented from fishing in a lake that is private property. Here I'm referring to fish in the middle of the ocean, outside of any territorial waters, where you can't prevent anyone from going out there and fishing, throwing their nets. So it's not excludable, but it is rival. Every fish one boat takes out of the ocean is one less fish for the other boats. Now, not goods that are non-rival but are excludable. These are club goods. An example, satellite radio, movies. Think of, I think cable TV is an easy example. It is excludable. If I don't pay my bill, they turn it off. But it's not rival. If I watch HBO, it doesn't mean there's less HBO for you to watch. Then the topic of this chapter, the bottom right, public goods. These are things that are non-rival and non-excludable. These are studied quite a bit because they're important public policy implications and because it is, from an economic perspective, vexing. It's difficult to create a system where the optimal level of public goods are provided. Two simple examples: fireworks, national defense. If a fireworks display is provided in your town, it's not excludable. They can't stop anybody from looking up and going, ooh, ah. They can't say, well, you didn't contribute to the cost of this, you can't watch. Doesn't work. But also, it's not rival. If I look up at the fireworks and enjoy it, that doesn't mean there's less fireworks for you. National defense, same thing. If our national defense protects me, well, it also protects the person across the street. You can't tell someone, well, you didn't pay your taxes, so we're not going to protect you against a Martian invasion. But it's also non-rival. Protecting me doesn't mean there's less national defense for you. Okay, public goods, non-excludable, non-rival. Here's some more examples. Broadcast radio and TV, meaning free over the air. Public highways, assuming they're not toll roads. National parks, assuming that you don't have to pay to get in. Clean air. Now, reservation price. The concept of reservation price makes discussing these much easier. In very simple terms, a reservation price is the amount you think something's worth. That means it is not necessarily how much you're going to pay for it, but it is the most you would pay for it. It's a price such that you would be just indifferent between paying the price and getting the thing, or not paying the price and not getting the thing. If we assume your wealth is W, then the utility of not having that good, and this second term here is a binary, do you get the good, do you not? In this first case, the utility of not getting the good is, well, you keep all your wealth, but you don't get the good. The utility of buying it is, if it costs P, your wealth minus P, but you do get the good. The reservation price, R, is the price you would have here, such that these would be exactly equal. So this is the price that you think it's worth just this much, but no more. All right, assume the public good. First case, should the public good be provided? Is it a Pareto improvement to provide the good? Remember, Pareto improvement. The strict definition is strict-ish. Is a Pareto improvement is something that can make at least one person to some degree better off, while not making anyone worse off. Here we're using a looser definition. A Pareto improvement is something that can make everyone better off to some extent. Pareto optimal is the state where it's the allocation where it is no longer possible to make any more changes like that. From that point, you can't make everyone better off. You can't make anyone better off without making someone worse off. That's frequently called Pareto optimal. The book calls that Pareto efficient. Same thing. Okay. The one unit of the good costs C. There are two consumers, A and B. The amount each consumer does pay for the good is G. So, if you want to provide the good, well, it costs C, so the total of what person A spends and B spends has to be at least as much as the good costs. Now, those payments have to be rational. Pardon me. Meaning that individuals will only buy a good if the utility from doing so is greater than or equal to the utility of not doing so. Which means, for person A, the utility of, let's go the right side first, the wealth of A minus what they spend on the public good, but they get the good, that utility must be greater than or equal to the utility they get from just keeping all their wealth, for it to be rational for them to do this. Same for person B. What this means is that for person A, for it to be rational to buy the public good, the amount they have to pay for it has to be less than their reservation price, less than what they think it's worth. If they had to pay more than they thought it was worth, it would not be rational to do so. Same must be true for person B. So, the utility of purchasing the public good for person A has to be greater than the utility of not purchasing it. That also must be true of B. So, it is a Pareto improvement if the cost of the thing is less than the total amount people are willing to put towards purchasing it. The benefit to person A plus the benefit to person B must be greater than the cost. This is a sufficient condition for supplying the good to be efficient. Does that mean it will be provided? Sadly, no. First case. Assume that the reservation price of person A, how much person A thinks having this good would be worth to them. Let's assume that's greater than the cost of providing the good. Let's assume the same is true of B. Well, then person A is going to be willing to supply the public good no matter what B does. If B did not exist, person A would buy it. Let's say it's a fireworks show. Costs $1,000. C. Person A thinks being able to look up at a fireworks show is worth $1,500. Person A will buy that fireworks show. Doesn't care who else is going to look up and enjoy it. Doesn't care how much other people value it. But if this were the case, where both people valued the show more than the entire cost of the show, they would both be willing to foot the whole bill. Doesn't mean that they will, because each might know that the other is willing to do that. So person A might think, I really want a fireworks show. I'd be willing to pay the whole thing myself, but I think B might buy it. So I won't. I'll pay nothing and watch the show for free after B buys it. And B would think the same thing. They would each be attempting to free ride on the other. The fireworks show would not be provided, even though it would be efficient to do so, to provide it. Now let's look at the next case, where the reservation price of each person is individually less than the cost of the good. Well, if person A thinks it's worth $900, but the show costs $1,000, and person B, let's assume it's identical, person B would be willing to pay $900 to see fireworks, but the show costs $1,000. Neither one of them are going to purchase it. Now, I should note, here, when we say private provision of a public good, I mean that each person has a binary choice. buy the whole thing or do not buy the whole thing. And there is no possibility of an agreement between the two. It's a private choice. Here's an example. Let's assume that there are two roommates, A and B, and they're deciding whether to buy a TV. This is very similar to, but not quite identical to, the prisoner's dilemma we saw in the game theory chapter. Now, in this apartment, the TV has to go in the living room for whatever reason. There's no way one roommate can stop the other from watching. Let's assume there's only one channel. The TV costs $150. Each roommate has a private reservation price, a private willingness to pay of $100. Each would be willing to pay up to $100 for it because they get $100 benefit from having a TV in the living room. Also, more than one TV doesn't benefit them any more than having just one. Okay, let's look at this from a game theory perspective. Let's see, how about blue? All right. Whoop. Or green. Player A is deciding what to do. And player A thinks, well, if my roommate B buys the TV, well, then we'd be in this left-hand column. What should I, as player A, do? Well, if I buy the TV also, we'd end up with two TVs. I'd have spent $150 for something that I only value at $100. I'd be down $50. If I don't buy it, but B does, I get to watch TV for free. I get $100 benefit. So if B buys the TV, I should... Oh, you can't see that at all. All right, let me fix that. One moment. There we go. If player B buys, player A should not buy. But then player A thinks, well, what happens if my roommate B does not buy the TV? What should I do? Well, then player A has a choice between buy the TV, the top right, and again spend $50 for something player A only spend $150 on something that the player only values at $100, so it would be $50 worse off, or don't spend it and be even at $0. So again, player A should not buy the TV. For player A, don't buy is a dominant strategy. Player A should not buy no matter what player B does. These numbers are symmetrical, so you can see there's the same issue for player B. Player B should not buy no matter what player A does. Bottom right, don't buy, is the Nash equilibrium, even though it's not the efficient outcome. Either one of the top right or bottom left, the group as a whole would be better off by 50. They could divide that up. They'd both be better off, but they won't get there. It's not a Nash equilibrium. Now, here's a slightly different example. A and B. Let's say the public good here is buying a window air conditioner for the apartment. Two air conditioners, no better than one. The air conditioner costs $100. They have different preferences this time. It's not symmetrical. Roommate A thinks having air conditioning would make him $80 better off. Roommate B thinks having air conditioning would make her $65 better off. Now, the total benefit to the group is $145, and it only costs $100 to get it. So it is a Pareto improvement to supply this public good. Now, these numbers are different and they're not symmetrical, but you have the same problem as before. Player A thinks, well, if B buys, what should I, A, do? Well, if I don't buy it, I think air conditioning is worth $80. I get $80 of benefit. If I do buy it, I've spent $100 for something that I only value at 80. I'm worse off by 20. So player A here would not buy. But if player B does not buy, then player A is faced with the same problem. Buy, you spend $100 for something you only think's worth 80, or don't buy and stay even. Don't buy is a dominant strategy for player A. For player B, the numbers are slightly different, but still it's a dominant strategy not to. For example, if player A buys and player B does not, player B gets $65 benefit. Okay, so you have the same problem. But now, assume that they can coordinate. They can talk to each other. They can negotiate. So now, they don't have to pony up the whole price by themselves. They can each pay part of the price. They could negotiate. Maybe they come to this agreement that A will put in 60 and B will put in 40. Totals 100. They can buy the AC unit. But now they have to make individual choices whether to contribute those amounts. Okay, player A. If player A is thinking of strategies. If player B contributes the money, then we'll be in this left-hand column. Player A has a choice. Spend the 60, contribute 60, and get something that player A thinks is worth 80. That would be plus 20. Or don't contribute. That means no air conditioning. Player A hasn't spent anything, but doesn't get air conditioning. It would be 0. So player A, in this case, will contribute. But player A thinks, well, what happens if player B doesn't contribute? Again, if player A does not contribute, they get 0. If player A does contribute, player A has just essentially flushed $60 down the drain. Player A doesn't have the 60, it goes away somewhere. But also no air conditioning. That's not good. So, let's look at it from player B's perspective. If player A contributes, then we're in the top row. Player B, if player B does not contribute, no air conditioning. If player B does contribute, then player B has spent $40 on something that player B thinks is worth $65. $25 better off. But if player A does not contribute, and we're in the bottom row, player B, well, doesn't want to spend 40 and get nothing, so player B would spend nothing, would not contribute. Now, because they can each contribute a portion of the price, there are two Nash equilibria. Contribute, and not. Doesn't mean they'll end up at the contribute option, but at least it's possible. Okay. Now, allowing contributions of partial price of the public good. makes it possible to produce a public good when no individual is willing to do it by themselves. Does that mean that it's going to happen? Well, maybe. Let's assume here that C of G, G is a unit of the public good, and C is the cost. It's no longer should we simply buy this one thing or not buy this one thing. Here, you have to decide how much of it to buy. How much national defense? Again, two individuals. The wealth of person A is WA, the wealth of person B is WB. The amount they spend individually on the public good is G sub A and G sub B. Their private consumption, their wealth that they spend on everything other than the public good, is X sub A and X sub B. So, this is their budget constraint. The total wealth of the society, the wealth of A plus the wealth of B, has to equal the amount of private consumption for each person plus the total cost spent on public good. The book talks about the marginal rate of substitution for player A, marginal rate of substitution for player B. Between private and public goods. This is not the way I would explain it. If the private good, well, spending on all private goods, well, that's money. You know, what's the cost of one generic unit of spending? It's $1. And if you assume that the cost of a unit of a public good is $1, then yes, this is mathematically correct. It's not terribly intuitive. The better way to think of this is that the marginal utility from spending $1 on a public good from person A and the marginal utility of spending $1 on a public good for person B, that total has to equal the total spent on the marginal cost of the good for it to be efficient. Think of it this way. If people thought $1's worth of a public good is worth more than $1, so if this was not an equal sign, if the total was greater, well, then it would be a Pareto improvement to spend more. That would mean you're not at the efficient allocation because you want to change. If people thought the reservation price for the first person plus the reservation price for the second person, the total amount that collectively they think it's worth was less than the marginal cost of one more unit, then they're overspending on public goods. They could have a Pareto improvement by reducing total spending. They're only at the Pareto optimal level of spending when this is an equality. So, let's see. So, this is the efficient level, the Pareto optimal level of total spending on a public good is such that this is true. The reservation price for one person plus the other person equals the marginal cost of the good. This is it graphically. This is the reservation price for person 1, for person A. This is for person 2, and it varies depending on how much of the good there is. as the amount of public goods supplied increases, these people are both less willing to purchase one more unit. It is the sum of these two marginal rates of substitution, which is the total marginal utility of buying various quantities of G. The efficient point is where the total marginal utility equals the total marginal cost. Well, there is only one cost. It's a public good, so equals the marginal cost. Now, if there were more than two consumers, well, it's logically the same. If they're end consumers, then the optimal level of public good for the society to consume is the marginal utility for one more dollar of the public good is exactly equal to the marginal cost. The marginal cost has to equal the reservation price summed over all the people in the community for that particular quantity of public good. Means total benefit has to equal total cost at the optimal point. Now, when is free riding individually rational? This brings up another constraint. Well, that is our kitty, Gracie, coming in to say hello. Hello, Gracie. I'm teaching. Oh, someday we'll be back to normal. Okay. This introduces another constraint, which is why in the very first slide I showed you was multivariable optimization with constraints. This constraint is that an individual can only supply a non-negative quantity of the public good. Then assume person A contributes this much, GA, to the public good. Then person B has this optimization problem. Maximize the utility of yourself, person B, but that's a function of the amount of private spending person B has and the total spending on the public good. Because person B gets utility from the total amount of public good. A constraint. The total wealth of person B has to be equal to private spending for B and the amount B spends on the public good. Also, person B cannot spend a negative amount on the public good. And all of this is also true from A's perspective. Now, this is it graphically. The slope, this is the budget constraint for person B. The slope is -1 because we're assuming, it kind of looks like -1, that the price of a unit of consumption on a private good is 1, and the price of buying $1 worth of public good is also 1. Simplifies matters. So, this budget constraint, person B can exchange public good and private good for any of these points. If person B wants to spend all their money on this commodity, they would be here. All their money on that commodity, they would be here, if they were normal goods, not public goods. And any combination in between. But these are public goods. Person A has already decided to purchase this quantity of the public good. All right. That makes person B's budget constraint this segment, the red segment of the budget line, because person B cannot provide a negative amount of the public good. Player B's budget constraint is limited to this segment. Why? Let's look at it this way. Forget about how much of the public good person A is providing. This is just person B. Okay. This is from your principles course. Here's a budget constraint. Here are indifference curves. The utility maximizing combination of this good and that good is where the budget constraint is tangent to the highest indifference curve. It'd be this point right here. This quantity of private spending and this quantity of the public good makes person B happiest. But that Econo-Kitty. Yes, but that's not possible, because that would require, at this point, that person B have less of the public good than person A has already provided. Person B would have to convert some of the public good provided by A into private spending. But person B, in practical terms, the smallest amount they can spend, the smallest amount of public good they can have, is this amount. They can't have less than that because this is the amount person A purchased, which means this is as close to optimal as they can get. They can't move farther down this way. Imagine person B spent all their money on the public good. All right, they would have this much. And they'd think, I can do better. I'll reduce my spending on public good. I'll have more private good spending, and then I'll do it some more, and then I'll do it some more, then I'll do it some more. At this point, person B is spending nothing on the public good. They can't go farther to the right. So they end up here, spending nothing on the public good. They're free riding. This is what's called a corner solution, because the optimal choice is not where the budget constraint is tangent to the indifference curve, because essentially they've run into the corner. They can't go further. Now, in our discussion of private goods, let me back up. How do private goods compare to public goods? Adam Smith, in The Wealth of Nations, in 1776, wrote, "Every individual necessarily labor." By necessarily, he means does, not intends to. Every individual necessarily labors to render the annual revenue of society as great as he can. He generally neither intends to promote the public interest nor knows how much he is promoting it. He intends only his own gain. And he is in this, as in many other cases, led as by an invisible hand to promote an end which was no part of his intention. Now, the first fundamental theorem of welfare economics is that a competitive market, equilibrium, leads to a Pareto efficient allocation of resources. That's just a mathematical restatement of Adam Smith's invisible hand, relating competitive equilibria to Pareto optimality. But each consumer deciding for him or herself how much to purchase of various goods would result in a pattern of consumption that was Pareto efficient, or Pareto optimal. So each person optimizing with respect to his or her own private consumption is a sufficient condition to achieve a kind of social optimum. to maximize the total surplus of the society. Excuse me. However, a competitive market includes assumptions. That there is no market power among the buyers or the sellers, no monopoly, for example. It also assumes that there are no externalities, that each buyer receives the full benefit of the thing they buy. No one else gets any of the benefit. And each seller, in producing, pays the entire cost. Well, actually, it's benefit and cost on both sides. That there are no externalities. But when we're dealing with public goods, there are externalities. In particular, with public goods, there are positive externalities. When I purchase national defense, it benefits you. It benefits everyone. Now, remember, when there's a negative externality, the quantity of production will be higher than the efficiency maximizing equilibrium would be, because the producer is not paying the full cost of production. And when there's a positive externality, the total level of production will tend to be lower than the efficiency maximizing level, because the person making the choice is not getting all of the benefit. This is the case with public goods. So we're not going to reach, using a purely free market solution, we're not going to reach that Pareto-optimal level of production of the public good. What are the solutions? How can we deal with this? Well, there are several. How can we reach the welfare maximizing production level of a public good? One, like with any other externality, all you have to do is internalize the externality. You could have one person buy out the entire economy. Then that one person would be paying the entire cost and receiving the entire benefit. No externality. Not practical. Although Elon Musk is probably headed in that direction. Second, command. You can have one person or a group of people simply figure out as best they can what the efficient level of public good is, and then just order everybody to do that. Well, that doesn't work well, because dictatorship is inefficient. Even when it's benevolent. Obviously, dictators tend not to be benevolent. You give too much power to someone, bad things happen. It's certainly a lesson of history. But in econ, we have the concept of the benevolent dictator. Someone who has all power in a society to make economic choices, make all the economic choices, but is perfectly benevolent. The person wants to maximize the welfare of the society. Even with a benevolent dictator, it is impossible to reach the efficient level of provision of a public good, or efficient level of provision of private goods. See the socialist calculation debate. F.A. Hayek proved, and later it was mathematically proven, that this can't be done, because a central planner, no matter their intentions, doesn't have access to all the information necessary to reach the optimal equilibrium. All right, so that doesn't work. What about democracy? Use some sort or other of voting system to decide how much of the public good we're going to provide. This also can't work. It cannot reach the best allocation of resources, with a little more complicated definition of best, but still. No voting system can do that. Not just our system doesn't, or another system doesn't. It is not possible for any voting system, conceived or yet to be conceived, to reach that optimum result. Arrow's impossibility theorem. Robert Arrow, who probably should have won half a dozen Nobel Prizes, not just the one. Google Arrow's impossibility theorem. The math is rough, but you'll see an explanation of why this can't happen. The last option to fix this problem is for you to study more econ. Then go to grad school, get a PhD in economics, specialize in, it's called public choice theory, and be so good at it that you solve this problem. And I guarantee you, you will win the Nobel Prize for it. In the meantime, it's something for us to study and economists to work on. Anyway, that's it for this lecture. I'll see you next time.